So I stopped the circuit, like the electrolysis circuit, and the electromagnet circuit is still I kept it on, but I stopped the electrolysis because it was starting to burn, as you see, and so I need to tweak it in order so it will not burn. This happens sometimes, as I said, with electrolysis, and it could have various reasons. But so in order to complete the picture of, this experiment that we've done now, I saw that, it will be nice to actually take a bit of the foam that was created, because, it wasn't really, completely burned. When it's actually burned, I stopped it just before it was really, starting to burn. When it burns, it's like, it's like black and you can't see anything under the microscope. But it still wasn't like, it was still in like a pretty, okay condition when I stopped it. So we can actually take a sample of it and put it under the microscope. And it was very, very thick, very, very thick. The foam was like a bulb. You can actually roll it. Inside like roll the bulb of foam, and I dissolved it in the water before. After I took the sample, because I wanted generally that's what I do. I dissolve the foam when it's like part of the measure of preventing the burning, and when it is required. So let's take a look at what actually was created. Again, I refer to what was created. When we had this, the secondary electromagnet helper. It's still to be investigated what is effective at all, but it was for this reason or others that we need to discuss. There was considerably more action, surrounding the neutral rod, the white rod, especially taking into account that I moved it back to the initial place where it was much weaker than, if you remember when, it got much stronger when it was placed in the middle of the magnet. But I took it back to the weak place, and yet, as you've seen, it was crazy, and the foam was created in a very, very, rapid manner, and also fumes, and that's why I thought it's going to burn. But let's take a look at, at a sample of this foam. This is the sample, and let's take a look. So we see already both Niros and many duds, many things that are on the way. Okay, so this is, it looks, you can already say it looks like a thick foam that we've seen in the past, which is very rich in Niros, but even more so in, things that presumably could have been Niros if the process was completed, but it wasn't completed because I stopped it because I was afraid that it's going to burn. It actually happened quite. It's not unsubstantial. Substantiated fear, because it happened to me and it happens with electrolysis. If it burns, it's all black and you see nothing. No Niros and no nothing. So it's good that I stopped it. Just before it's starting to burn, and you can see here. Both bubbles and also Niros that look in a perfect shape, but many that look like they are on the way, and probably they are already dissolving right now as we speak. Okay, so yeah, this is we've seen such in the past such samples, similar samples in the past. It's not the first time. This one is really beautiful, like the thin one, just in the middle. These one are dads, like for certain, I mean, they will dissolve. Okay, so, well, it's still, I mean, no big surprise, just it was, I mean, important to establish that, I mean, that all this, like, action that we've seen was actually, I mean, the same type of action that we've seen in the past with the similar, with in this electrolysis chamber in similar conditions, which means like it's basically it's a good thing, like it's a process that is what we want to create Niros. But I mean, it was it's certainly if I kept like a little more, it was just starting to burn, and like I have enough like experience to know that it's just, and then it's like it's all black, like, and it's just ash or so whatever, like remnants of fire, and you don't want that. So so you've seen like in live, typical. I mean, I didn't know that it would turn out like that. I mean, it was like, I mean, you've done it like with you, the experiment, and you've seen like in live, like, I mean, a typical, I would say, experiment with, and like typical results, and like, I mean, I would say problem that arise with the electrolysis in general, and particularly in this, like, I mean, magnetic, like variation of electrolysis chamber, and these are like some of the practical stuff that I deal with. Like, I mean, you want it to, yeah, I mean, you want the action, like you want I mean, we need to specify like what exactly is the action, and I mean, I'll try to speak about it like in a more rigorous way, but I mean, we need the turbulence surrounding the rods, and actually it's kind of like, it could be like in both, like in the positive, like in the hot one and the neutral one, and this one is actually from the neutral one, but it's also a question of like what's the difference. So we'll speak about it, but I mean, we need like the turbulence surrounding the rods, because this is what creates the form, and from the form, like we see that new Niros are born, although actually worms. I mean, not in this kind of like, I mean, experiment, but in the past we've created several bit of like nice living worms. So I mean, it's I mean, and we if it's more active, like, I mean, so like more are created like in like shorter span of time. But I mean, if it's too active, then I mean, there is, as you've seen, it's a process. I mean, that you need to find a balance, and so it's related to many other like factors, like, I mean, the number of rods, and the quality of the rods, and the material of the rods, and the erosion, because they're eroded and they change, like, and the rods actually change, like, I mean, the metal is getting like tired, like, I mean, and I mean, so it also got like, in fact, among other like effects, it affects its, like, I mean, prosperity to like to magnetism, like, I mean, how it's like attracted to the magnet. And I mean, and galvanization, I mean makes like the whole like mixture, like full with metal particles, but also other particles that, I mean, that are from the mix, and the Niros themselves, I mean, are contributing, I mean, are changing, like are contributing greatly to the whole party. So yes, I mean, it's pretty typical what you've seen. It, I mean, you try to balance like between all sort of factors, and also add like new stuff, and see how it affects the whole like the whole operation. And like in the past, I've added like water, but I try to avoid it, because I try not to dilute, like sometimes I add ice, but it's only like, I mean, like a bandage, bandage, like, I mean, it's like something that is, if you really want, like, I mean, to keep it cool, like, very quickly. But it's also a problem, because in general, I don't want to dilute like the mixture with water. I mean, so I speak about all that in a separate video. But yeah, it was a good, I say, a good, very nice, like experiment, and with nice results. And like, also, I mean, the bad result is also nice, because it was demonstrated like what kind of things can happen, and like what problems arise in the when you in this type of electrolysis.